Okay, we retain another integral. This one's from the UNSW integration, be 2024, round 2, problem 7. We've got the integral from 0 to pi of the sum from n equals 1 to infinity of cosine nx over n all squared dx. Okay, when I did this the first time, what I did actually was just take this sum and just expand it out term by term, plugging in n equals 1, n equals 2, and then what we can do is just basically integrate each of these. Now, I mean, it's an infinite number of terms, so you don't really want to integrate an infinite number of terms. But what's going to happen when you write it out that way, what you're really doing is just swapping the integral and the sum right here. So we can actually just rewrite this with the sum first and then the integral on the inside. And when I do this, I'm going to just distribute in the power and square each of the terms inside here. So this is going to become cosine squared nx over n squared dx. But then here, notice we're differentiating with respect to x. We have this n squared here, which is just a constant with respect to x. So what I can do is take this out front here as 1 over n squared. But now from here, what I can do is just focus on this integral that we have right here. And so what I can do is use the power reduction on this. And when I do that, we'll end up with 1/2 plus 1/2. And then we're going to double the angle. So this is going to become cosine 2nx. But then we'll just go ahead and integrate. So this is going to become 1/2 x plus 1/2. Here, this is going to become sine 2nx, but we need to bring out this 2n, so we'll bring out this 1 over 2n here in the denominator, and this is all evaluated from 0 to pi. But this right here I can multiply together and write as 1 over 4n. Then we can just evaluate this, but notice when we evaluate at 0, this is going to be 0, sine at 0 is 0, so we don't need to worry about that bottom term. Then evaluating at pi, now notice because n is going to be an integer value, 2n times pi, that's always going to be 0. So this piece here is going to be going away. So we just need to plug in pi right here, and we just get pi over 2 for that piece. But then we can just take this here, plug it back into our summation, and finish it off. Okay, so now at this point, all we've got left is the sum from n equals 1 to infinity of pi over 2 times 1 over n squared. This here is a constant value, so I could take it outside of the sum. So then I can do a quick rewrite. We've got pi over 2 times this sum, and all we have left is 1 over n squared. But this thing right here, this keeps coming up over and over again recently. This is just the Basel problem. We know that this value is going to be just pi squared over 6. So in order to finish it off, all we need to do is multiply pi over 2 times pi squared over 6, and we get our final solution of just pi cubed over 12. Okay, there you have it. Really good problem from UNSW 2024. Thanks everyone for watching. Have a good day.